So we have discussed first order differential equation. One method is variable separable, second is homogeneous, third is linear, fourth is exact. So sometime one question can be solved by a couple of methods. So you can have a couple of methods for solving one single question. In exam it is not mentioned which method you are following. So you can have either you can have homogeneous or linear or whatever it is. So make sure you should understand this. Let z is equal to fxy be a surface and fxy equal to c be level curves. When a surface is intersected by constant plane, then we are getting level curves. In level curves you can have the derivative, here you can differential. So dz, the differential of this surface, can be written partial f over partial x dx plus partial f over partial y dy. This is the differential of this. Let me for the derivative for this. So fxy equal to c or equal to 0, this is implicit function. The form of implicit function is fxy equal to 0, in which y is a function of x. So let me have d by dx of f of xy is equal to d by dx of c. This is going to be 0 because the derivative of constant is 0. Here partial f by partial x dx by dx, because x is a function of itself, but y is a function of x. Make sure I am using implicit differentiation. A partial f by partial x plus partial f by partial y dy by dx. Look at that, dy by dx. Here I am taking the derivative of the level curve, and here differential of the surface. Look at that. Multiply by dx. This equation is multiply by dx. So you are getting partial f by partial x dx plus partial f by partial y dy equal to 0. Look at that. This is going to be partial f by partial x dx, partial f by partial y dy. Let partial f by partial x is m and partial f by partial y is n. Call it equation 1. Equation 1 can be written. कैसे भाई? m dx plus n dy equal to 0. If you remember, partial f by partial x is my m and partial f by partial y is my n. Now if fxyc is continuous, then mix partial derivative are equal. This is mixed partial derivative are equal if the function is continuous. This level curves, these are continuous. Partial derivative are equal, that is fxy is equal to fyx. These are partial derivative, mixed partial derivative. If you are differentiating with respect to level curve is there, if you are differentiating with respect to x, the answer whatever you are getting, differentiating with respect to y, that must be equal to if you are differentiating with respect to y and then with respect to x. Now let you call it 2. Equation 2 will be an exact differential equation if, look at that, partial m by partial y is equal to partial n by partial x. Look at that, because here m is a function, m is differentiating with respect to x. It means you have to differentiate this with respect to y. And then since this is the derivative with respect to y, first you have to differentiate this with respect to x. So mixed partial derivative. This is going to be partial f of partial x partial y. You look at that. With respect to x it is differentiating, so you can differentiate with respect to y, and this with respect to x. If both are equal, partial derivative are equal, this is the format. This is the format of exact differential equation. If both the partial derivative are equal, then equation is exact. Equation 2 will be an exact differential equation if the partial derivative are equal. Now make sure you are differentiating m with respect to y or n with respect to x, because m and n we are labeling like this. And mixed partial derivative, look at that, function is continuous. These are the derivative, fxy is yx. It means this is with respect to x, so you have to differentiate this with respect to y, and this with respect to x. This I have written. Equation is an exact. Solution of equation 2 will be written if the partial derivative are equal, it is an exact. So I am writing down the solution. The solution is written. Let me rub this. Solution is written m x y dx, integrate whatever your m term by term with respect to x, plus terms in n independent of x. You have to choose those terms which are not having x in it. Terms in n independent of x. If there are two terms, both are having x with it, put 0 there. And then if you are writing those terms which are independent of x, integrate with respect to y, and do not forget to put a constant of integration. So if exact equation, if both of the partial derivative are equal, equation is an exact, and this is the way you are writing down the solution. Examples. Solve the following differential equation. Solve the following differential equations. So let us solve. Number 1, 4x minus y dx plus 6y minus x dy equal to 0. Number 2, 2xy square plus 3x square dx plus 2x square y minus plus 4y cube dy equal to 0. Let me have these two and then we'll move this. Now exact differential equation, the format is m dx plus n dy equal to 0. This is the format for the exact differential equation. Dx, solution of question number 1. Let mxy is equal to 4x minus y, and let nxy something with dy is 6y minus x. Partial derivative of m with respect to y is minus 1. Partial derivative of n with respect to x is minus 1. Since both of the derivative are equal, so equation 1 is exact. Equation 1 is an exact differential equation. If it is exact differential equation, let me write down the solution the way I have written. I am writing down the solution. The solution will be, this is 4x minus y, integrate term by term with respect to x. mxy dx integrate with respect to x plus terms in n free from x. So I have to write 6y dy equal to 0. Let me integrate. This is with respect to x. X square by 2, which is 2x square minus xy plus 3y square equal to c. Y square by 2 and that's 2, 3 is 6. This is the solution of a exact differential equation. Or you can make it homogeneous as well, because this and this are homogeneous function. Homogeneous function, put y is equal to vx. You can have the same answer. Let me have the other. Let me solve the second question and then there are a couple of follow-ups for you to solve. Second question, mxy is 2xy square plus 3x square. nxy is 2x square y plus 4y cube. Let us have the partial derivative. Partial m by partial y, 4xy. Partial n by partial x, 4xy. Look at that. Since the derivative are equal, 4xy, the equation is an exact. If it is an exact differential equation, how to write down the solution? Whatever your m is, this is 2xy square plus 3x square dx. Term in m, integrate term by term with respect to x. Sara likh dena. So everything is there and you have to integrate term by term. Then n, terms in n free from x. Let me write one term, which is y cube dy equal to 0. Because this term containing x in it, so you are forgetting it. Integrate with respect to x. X square by 2 cancel. This is x square y square plus x cube by 3. 3 cancel. This is x cube plus y4 by 4. 4 cancel. The y4 equal to c. So this is the solution of first order exact differential equation. Right? Let you have the follow-up. So couple of follow-up, you student to please try to solve and then we'll discuss if you have any problem. So follow-up. Solve the following differential equations. Number 1, y cube plus y over x dx plus y square plus ln x dy equal to 0. Number 2, 1 plus y exy dx plus 2y plus x e xy dy equal to 0. Number 3, x plus tan inverse y dx plus x plus y over 1 plus y square dy equal to 0. Fourth, 2x over y minus 3y square over x4 dx plus 2y over x cube minus x square over y square plus 1 over y under root dy equal to 0. Exy plus x exy dx plus x ex plus 2 dy equal to 0, y 0 is minus 1. Right. So these are couple of follow-up 1, 2, 3, 4, 5. So you can solve by using the methodology which I have discussed: variable, separable, the homogeneous, the linear, the exact, and these are going to be exact. So making the partial derivative whatever with dx, this is your m, you have to differentiate partially with respect to y and this with respect to x and see whether the partial derivative are equal, yes or no. If they are equal, you have to find the solution. But here in the fifth question, and condition is given. It means once you solve, there is a constant of integration. That constant can be determined by applying the condition this. Here x is equal to 0 and y is equal to minus 1. At the end, where this c is there, replacing x by 0, y by minus 1 and finding the value of c, then putting back in the solution. So we have finished first order ordinary differential equation by studying all the four methods: variable, separable, the homogeneous, the linear, the exact.